We're going to be looking at some applied problems where we end up using logarithms in our solution. Let's look at this first one. It says, how long will it take $5,000 to triple in value if the money is invested in an account earning 4% interest compounded continuously? And so they didn't say it specifically, but we're going to assume that this is per year. First of all, let's think about what we know here and what we're given. We're given that our interest is compounded continuously. And if you remember, our formula for continuous compounding is future value equals present value e to the RT. Let's see what else we know. We know that we start out with $5,000 and it's going to triple in value. So we're starting out with a present value of 5,000 and the future value is going to be triple that. It's going to be 3 times 5,000, which is 15,000. We also know that our interest on our account is 4%, so our R is 0.04. And our goal is to figure out how long. Well, how long means we're looking for our time. So our equation that we have here, if we plug in all our knowns and unknowns, we have 15,000, that's our future value, is 5,000 e to the 0.04 t, and our goal is to find that t. So the first thing we're going to do is we're going to isolate the exponential. We're going to divide both sides by 5,000, and we get 3 equals e to the 0.04 t. Now one thing you might not realize right now, but it's going to come in handy later, is it actually doesn't matter how much we start with. We could start with 1,000 and triple to get 3,000, or we could start with 1,000,000 and triple to get 3,000,000. The time is going to be the same. What's important here is that we end up with 3. It tripled in value. So if we started out with a present value of whatever, and then it ends up tripling, we'd have 3 times our present value. And when you divide out that present value, you just get 3 equals e to the RT. And so it doesn't matter what you start with, the time is still going to be the same. Going back to solving this equation, we have 3 equals e to the 0.04 t, and our goal, remember, is to get t equals some number, who knows what it is. And so t is in that exponent, so to get it out of the exponent, we're going to log both sides. Since I've got a base e, I'm going to natural log both sides. So I have natural log of 3 is natural log of e to the 0.04 t. This 0.04 t can come down in front. That's one of our properties of our logs. So we have natural log of 3 is 0.04 t times natural log of e. And remember, natural log of e, that's 1. So our t is going to be the natural log of 3, and I just need to divide by that 0.04. That is approximately 27.5 years. So how do you would like her investment to double in value every 4 years? In part A, it says, what rate of interest would she need to earn if the interest is being compounded continuously? So in part A, we know it's compounded continuously, so the formula that we have is future value is present value e to the RT. And we know a couple of things, different types of information this time. We want our investment to double in value every 4 years. So my time is 4, and it's going to double in value. Let's see, and also our goal is to figure out what interest rate. Our goal is our R. Notice they didn't tell us how much we start with. We don't know if we start with 1,000 or 5,000. It doesn't actually matter, because if we start out with a present value of whatever it is, we're looking for doubling. So our future value is going to be 2 times our present value. So if we plug everything into our equation, we have 2 times our present value, because it's doubled, equals present value e to the r times 4, I can divide both sides by this present value, and I have 2 equals e to the 4r. My goal, remember, is to find r. R is stuck up in the exponent, so once again we can log both sides. So we're going to have natural log of 2 is natural log of e to the 4r. This 4r, because of those property of logs, can come out in front. So I have, and become a coefficient, we're going to have natural log equals 4r times the natural log of e. Remember, natural log of e is just 1. So all I have to do is divide by 4. So my r is going to be natural log of 2 divided by 4, which is approximately 0.173. So that would be 17.3%. So our answer for part A is 17.3%. In part B, we're answering a very similar question, but instead of telling us that our interest is being compounded continuously, this time our interest is being compounded annually. So let's write down our information that we know. So once again, we have our, whatever we start out with, our future value is going to be twice our present value. My time is 4 years, but this time it's compounded annually, so my m is 1 and my goal is my r. Since we're looking at annually, we're going to use regular compound interest. So we're using future value equals present value 1 plus r divided by m to the mt. And if I plug in my known information, what I'm going to have is 2 present value equals present value 1 plus r to the 4. I can get rid of these present values by just dividing both sides by that present value. So I'm going to have 2 equals 1 plus r to the 4. Remember, my goal is to find r. Now, every other time, or every other problem that we've done in this video requires us to use logs to solve. This one does not. And the reason why is we use logs when our variable is in the exponent. But notice that this is our exponent. We don't have the variable there. Our variable is our r, which is in our base. So we still have to get rid of the exponent, but we can get rid of the exponent here by taking the fourth root of both sides. So we're going to have the fourth root of 2 is going to be the fourth root of 1 plus r to the 4th. These are going to cancel each other out, because when you take the fourth root of a fourth power, you're just going to have 1 plus r is the fourth root of 2. And so my r is going to be the fourth root of 2 minus 1, which is approximately 0.189. So this tells us that if we're compounding annually, we need to earn 18.9%. One last problem. This time we know that the rate of growth in the revenue for a startup company is doubling every 3 months. We are supposed to determine to 2 decimal places the base for the exponential model y equals a times b to the t of the rate of growth in revenue as a function of t time in months, and then we're supposed to find the tripling time. So the first thing we have to do is find that base. So what we know is y equals a times b to the t. So let's look at our given information. This is our model. Our goal is to find our b. We need to know something else in order to come up with this. So it says that it doubles every 3 months. So when t equals 3, whatever we start out with is going to be doubled. And remember, with exponentials like this, if we think about if t equals 0, you're going to have y equals a times b to the 0. That is 1. So if we double that, then we're going to have 2a equals a b cubed, and we can use this to solve for our b. So I can divide out the a. So I have 2 equals b cubed, and then to find b, I don't have to use a log because my b isn't in the exponent. All I have to do is cube root both sides. So my b is the cube root of 2. So if we answer to 2 decimal places, the value of my b would be about 1.26. Okay, so now we can answer part B. So in part B, it says find the tripling time. So our goal is to find the t when we're triple. So instead of having a, we're just going to have 3a. We're going to have 3a equals a. Remember, we had 1.26 for our b to the t, and we're solving for this t here. Notice that t is in the exponent, so I'm going to need to use a log, and I want to isolate that exponential first, so I want to divide both sides by a. So I have 3 equals 1.26 to the t. I'm logging both sides, so I'm going to have, let's use common log this time. Log of 3 equals log of 1.26 to the t. This can come down in front and become the coefficient. So I'm going to have log of 3 is t log of 1.26. All I need to do is get rid of this log of 1.26. So I'm going to divide it out. So I have t is log of 3 divided by log of 1.26, and the estimate for that is approximately 4.8 months. So it's 4.8, and then because t is in months, it's going to be months. That's it for this video. Hopefully you enjoyed learning a little about how to use logs in solving applied problems.